Welcome to the second producer's notes for Digital Combat Simulator Black Shark. In this note, we're going to take a close look at the ABRIS navigation system, Advanced Moving Map System, AMMS. The ABRIS is one of the two navigation systems on the K50, the other being the PBI 800 inertial navigation system. Now, it's important to note that the two navigation systems are completely independent in that they don't cross-link any information between the two of those. So whereas the PBI 800 is, again, primarily INS, the ABRIS is primarily satellite navigation system. Now, the ABRIS provides some very interesting capabilities. The first, of course, being the moving map, but also it allows you to create new routes, edit routes, import new routes that were saved earlier. You can display threat information in terms of enemy coverage, the ability to have data link information from your wingmen, and you could also place icons and annotations on the map as well. So all in all, pretty darn handy. Now, the ABRIS itself, of course, consists of the display. You have 5 line select keys, LSKs, along the bottom, and you have 2 rotating dials on either side. Now, the one on the left, rotating, allows you to adjust the brightness of the display. The one on the right is used to select different lines within a menu, and it also has a Z-axis to push, so you can select items as well. Now, the ABRIS has 4 primary pages, and those can all be cycled through using the rightmost LSK button. So right now we're looking at the menu. Then we go to the navigation, the nav, which is essentially the moving map, the ARC mode, the HSI in digital form, and then back to the menu. Now, most folks will probably be spending most of their time in the ABRIS looking at the moving map system. So let's take a look at that one first. So here we have the moving map with our aircraft here in the middle. The blue dots represent waypoints, and the blue line represents the course between each of the waypoints. We have our mode up here at the top, the north arrow. These are our track angle, the satellite feed status, and local time, either Zulu or local. In the center, we have the cross-track error scale. In the left side, we have the current aircraft information, which includes our ground speed, our bearing, the total time the aircraft has been in the air so far, the altitude, and current coordinate. To the right of that is our vertical error, and then to the right of that are data columns for the first and second waypoint here. And within each of those we have the desired track angle, the distance, and the ETA to those 2 waypoints. Below that we have our message bar, and then below that we have subpages that we can link to. So let's take a look at the first one, which is our search function. And from here what we can do is we can actually search out different airports, VORs, non-directional beacons, waypoints and towns near our position. So for example, I will scroll down to non-directional beacon, hit the search button, and this will now give me a list of all the different non-directional beacons in the world, from closest to furthest away. And using the rotating knob, I can now cycle through all those, and as I select each NDB, it places an NDB in the center of the screen. It gives me its name and its distance from my current location. And again, you can do this for all the different types of map objects. Also here we have the to function, and all that really does is if you have a multi waypoints in your flight plan, you can hit the to function. It'll simply make a very simple flight plan consisting of 1 waypoint that goes to your current steer point. We can also now go to the info, and this will give us information about the current steer point we have selected as well. Coming back, we'll look at the map functions. The most important ones being the scales. So we can scale in, and we can scale out. And here we see the entire flight plan now. We can go to the info button, and what this does is it gives us a red box on our current aircraft position, and by using the right dial we can spin it to move it in the horizontal, and then we can click on it to change it to the vertical axis. So I'm going to go ahead and put it over this NDB up here, hit the info button, and now it gives me information about that NDB. And again, I can do that for any map object within the world here. Coming back out, I can go to the ERBL function, and instead of a red square, we have a red cross now. And by moving the cross around in the same manner, I get a distance and bearing from the cross to my aircraft. Now, if I wanted to have a bearing and range information from the cross to an arbitrary point, I can click on the marker function, and now the cross moves in relation to that new marker, and I have a bearing and range between the cross and the marker now. Coming back out, I go to the flight plan page, FBL, and this gives me a table that lists the entire flight plan. So as I move my dial here, I'm going through the different waypoints, 3rd, 4th, and 5th, each highlighted. Now, if I want to make, say, waypoint 2, my active waypoint, I just simply click on the waypoint button, and that makes this green, which indicates it's active. In the rows here, we have our headings, wind conditions, airspeeds, distances, ETAs, fuels, and temperatures. Now the suspend, which is an interesting name, allows you to cycle your current steer point between the waypoints in your flight plan. So by simply clicking on this repeatedly, you can cycle through your flight plan. So that's a summation of the navigation page. So now we'll take a look at the menu page. So here on the menu page we have timestamps for all the information when it was first entered. We have the status of our sensors, the GNSS, which is our satellite navigation system, and our radar altimeter. So we'll first take a look at the GNSS. And this set of concentric circles represents the current satellite constellation that is feeding us. So every green circle you see is a valid signal we're getting, and the gray one represents an invalid signal that we're getting, and these are the different thresholds. So as you can see, satellite 30 is below that threshold there, and it looks like we have a total of 9, with 8 being serviceable. And what we can also do is we can hit the calculate button, and you can enter the aerodrome code here, hit the enter button, and that would give you the satellite constellation over that point in the world. So it's a little handy tool to make sure that you're going to have good satellite coverage between your start point and your end point. So coming back to the GNSS, we can also go to the system, we can run a system test. So let's kind of look at the satellite system. Come back out to menu, we'll go to options now. And the main options page gives you, as you might imagine, the main options that run through the ABRIS. Things such as the map orientation, map scale, local times. But probably one of the most useful ones will be down here at the RMIs 1 and 2. And these give you navigation indicators on your ARC and HSI pages. So right now we have RMI 1 set to steer point, which is pretty handy. But we'll go ahead and we'll set RMI 2 to the radio beacon that we have currently dialed into our ADF. So I have selected, I'll go to change, down to radio. Now if we go back to our ARC, we'll see that the yellow chevron indicates our steer point direction, and the red one indicates the direction to our radio beacon. Also within the option page we have some submodes. So right now we're in main. We can bring that down to units, and we can display either metric or imperial. We can come down to performance setups, the alarms that sound during these conditions, and our charts, which can also be pretty handy given that the moving map can sometimes get a little bit cluttered. So all you have to do is select a particular type of map object, hit the change button to either plus or minus.